Okay, now this is problem number 2. It says a single phase transformer has 800 turns on the primary winding and 400 turns on the secondary winding. So we have a transformer on the primary side, it has 800 turns, and on the secondary side we have 400 turns. The cross-sectional core area is 50 centimeters squared. If the primary winding is connected to a single phase 1000 volts 60 Hz supply, calculate for A the maximum value of the flux density in the core Bmax and the induced voltage in the secondary winding. Okay, so this is an easy test for us. It says we have to calculate what is Bmax. Well, Bmax is easily calculated with formula Bmax is equal to flux maximum divided by the cross-sectional area, AC, but we don't have the maximum flux, we don't have the flux maximum value of the flux, but we know from the formula that the induced voltage on the primary side or on the secondary, but for particular for the primary side, is equal to 4.44 times N1 times flux maximum times the frequency of the primary winding, times the frequency of the supply. We know that the induced voltage on the primary side is 1000 volts. We have the frequency and we have the number of turns on the primary side. So flux maximum is equal to the induced voltage E1 divided by 4.44 times N1 times the frequency. That is equal to 1000 divided by 4.44 times the number of turns is 800 on the primary side times 60. I can remove these zeros like this. We had 3 zeros up, 3 zeros down. And when I calculate this with my calculator, I get that the maximum flux induced in the cross-sectional area of the transformer core is equal to 4.69 times 10 to the minus 3 Webers. So the maximum flux density is equal to 4.69 times 10 to the minus 3 divided by the cross-sectional core area is 50 centimeters squared, but in SI units that is 50 times 10 to the minus 4, because we want to transfer centimeters squared into meters squared, and that is equal to 50 times 10 to the minus 4. And when I calculate this, I get that the maximum flux density in the core is 0.938 teslas. So this was for the maximum flux value of the core. Now for B, it says we have to calculate what is the induced voltage E2 on the secondary side. Well, we know that the turns ratio of a transformer is equal to E1 divided by E2, and that is equal to the number of turns on the primary side divided by the number of turns on the secondary side. From this, the E2, the secondary voltage, induced secondary voltage is equal to N2 divided by N1 1 times E1. So that is equal to 400 divided by 800 times 1000. I can remove these two zeros and I'm gonna calculate it. This is now 400 times 10 divided by 8. So the induced voltage on the secondary side is 500 volts. Let me just see the answers if this is okay. I get 0.934 Teslas, but that is pretty much close. So this is okay. And the induced voltage on the secondary side is 500 volts. So this also was okay. So thank you for watching and see you in my next